How? Reverse phase and normal phase chromatography for complex isolation. Hey everyone! Welcome back to our channel. Today, we're diving into a fascinating topic: how to isolate and purify caffeine, acetaminophen, and aspirin from a tablet using both reverse phase and normal phase chromatography. Sounds complex? Don't worry, I'll break it down step by step. Let's get started. To devise a separation scheme for isolating and purifying caffeine, acetaminophen, and aspirin from a tablet, you need to understand several key concepts related to their chemical properties. Here are the main concepts to consider. Solubility: each compound may have different solubility in various solvents. You can exploit these differences by selecting solvents in which one or more of the compounds are soluble while others are not. For example, you might use water, ethanol, or dichloromethane as solvents, depending on the solubility profiles of the three compounds. Polarity: the polarity of the compounds will influence their interactions with solvents and stationary phases in chromatographic techniques. Caffeine is a polar compound due to its nitrogen atoms, while acetaminophen and aspirin have different polarities. Understanding the polarity will help in choosing the right chromatographic method. Acid-base properties: caffeine is a weak base, acetaminophen is neutral, and aspirin is a weak acid. You can use acid-base extraction techniques to separate these compounds based on their ionization states in different pH environments. For instance, adjusting the pH can help to protonate or deprotonate certain compounds, making them more soluble in either the aqueous or organic phase. Molecular weight and size: the molecular weights and sizes of the compounds can also play a role in separation techniques such as size exclusion chromatography. Understanding these properties can help in selecting the appropriate method for separation. Chromatography techniques: various chromatographic techniques can be employed based on the properties of the compounds. Techniques such as thin-layer chromatography, TLC, high-performance liquid chromatography, HPLC, or column chromatography may be suitable depending on the scale of the separation and the desired purity of the compounds. Functional groups: the presence of specific functional groups, e.g., hydroxyl, carbonyl, can influence the reactivity and interactions of the compounds with reagents and stationary phases. This knowledge can aid in designing a more effective separation scheme. By considering these chemical properties and employing appropriate separation techniques, you can effectively isolate and purify caffeine, acetaminophen, and aspirin from a tablet formulation. Now, let's apply this knowledge to solve our specific problem of isolating and purifying caffeine, acetaminophen, and aspirin from a tablet. Step 1. Dissolve the tablet in a suitable solvent to get a mixture of all three compounds. A common choice is an organic solvent like ethanol, which can dissolve most organic compounds. After dissolving the tablet, we perform a liquid-liquid extraction. This process involves separating compounds based on their solubility in two different immiscible liquids, usually water and an organic solvent. Step 2. Add water to the ethanol solution. Here's where the magic happens. Aspirin is slightly soluble in water but more soluble in organic solvents. By adding water, we create a biphasic system where aspirin will mostly stay in the organic phase, while caffeine and acetaminophen will start to partition between the two phases based on their solubility. Step 3. Separate the organic and aqueous layers. Now we have two solutions, one with predominantly aspirin in the organic layer and the other with caffeine and acetaminophen in the aqueous layer. Next, we need to isolate acetaminophen and caffeine from the aqueous layer. We can adjust the pH to help separate these two compounds. Step 4. Acidify the aqueous layer. Adding an acid like hydrochloric acid will protonate caffeine, making it more soluble in the aqueous layer, while acetaminophen, being neutral, remains less soluble and can be extracted into an organic solvent. After acidifying, we extract acetaminophen into an organic solvent like chloroform or ethyl acetate. Step 5. Separate the organic layer containing acetaminophen. Now we have acetaminophen isolated in the organic phase, and caffeine remains in the aqueous phase. Now, let's talk about chromatographic techniques to further purify these compounds. For reverse phase chromatography, we use a non-polar stationary phase and a polar mobile phase. This technique is ideal for separating polar compounds like caffeine and acetaminophen. In reverse phase chromatography, caffeine and acetaminophen will interact differently with the stationary and mobile phases based on their polarities, allowing for effective separation. For normal phase chromatography, we use a polar stationary phase and a non-polar mobile phase. This technique is suitable for separating non-polar compounds like aspirin. In normal phase chromatography, aspirin will have stronger interactions with the polar stationary phase, allowing it to be separated from other compounds. Step 6. Recrystallize each compound for final purification. For example, dissolve aspirin in hot ethanol and cool it to get pure aspirin crystals. Repeat this for acetaminophen and caffeine using suitable solvents. And there you have it. By understanding the chemical properties of caffeine, acetaminophen, and aspirin, and using techniques like liquid-liquid extraction, pH adjustments, reverse phase chromatography, normal phase chromatography, and recrystallization, we can effectively isolate and purify these compounds from a tablet. To wrap things up, here's a quick summary. 1. Dissolve the tablet in an organic solvent. 2. Add water to create a biphasic system. 3. Separate the organic and aqueous layers. 4. Acidify the aqueous layer to separate caffeine and acetaminophen. 5. Extract acetaminophen into an organic solvent. 6. Use reverse phase and normal phase chromatography for further separation. 7. Recrystallize each compound for final purification. Thanks for joining us today. If you found this video helpful, give it a thumbs up, subscribe for more content, and check out our other chemistry videos. Happy studying, and see you next time.
Pharma